Now for this part, so calculate the molar mass of oxalic acid. Now, before doing any calculation, only one formula relates molar mass to number of moles. Number of moles is mass over mR. So then the molar mass is going to be equal to the mass of oxalic acid divided by the number of moles of oxalic acid. We have the mass, we need to find the number of moles of oxalic acid. So from the information that we have, actually, we have oxalic acid is being neutralized by the sodium hydroxide. So if we get the number of moles of sodium hydroxide, we can get the number of moles of oxalic acid by using the mole ratio. So let's find the number of moles of NaOH. So NaOH, I've used 24.9 of 0.1 mole per dm cube NaOH. So this is the information that we're going to use. So 0.1 mole NaOH, and I've used 24.9 centimeter cube of this. I'm not going to work in centimeter cube. Convert this to dm cube, so 0.0249 dm cube. Okay, so number of moles of NaOH, that's concentration times volume, 0.1 times 0.0249, that gives me 0.00249 moles of NaOH. Okay, I'm going to continue here. Now from the equation, see the equation here. 2 moles of NaOH reacts with 1 mole of oxalic acid. So I have the mole ratio. 2 moles of NaOH reacts with 1 mole of oxalic acid. So the number of moles of oxalic acid is going to be 0.00249 divided by 2. So which means that the volume of oxalic acid that was used, so 25 centimeter cube of this solution was oxalic acid, so 25 centimeter cube of solution, this contained 1.245 times 10 to the power minus 3. I calculated this from there. Okay, mole of oxalic acid. Okay, and so that's 25, but the original solution was 250. So 25, if I know how much there is in 25, so I'll know how much there is in 250. So there's going to be 10 times more. So that's going to be 1.245 times 10 to the power of minus 2 mole of oxalic acid. Okay, now I've got the number of moles. Remember, so we have to find the mR. So I have the mass, I've just got the number of moles. So then the mR is going to be the mass, which is 1. So from the question, that's the mass of oxalic acid, divided by the number of moles. That gives me 124 gram per mole. Okay, so that's the mR, and I'm giving the mR here to, so this is 4SF. So yeah, my answer should be to 4SF actually. So 123.8 gram per mole. Okay, but the SF here is not really important. Let's find the percentage uncertainty, and let's find the uncertainty, and then we'll see how many SF. So then the uncertainty, because we already calculated percentage uncertainty is 2%. So 2% of this value. So this gives me 2.48. This is the absolute uncertainty in the MR, but I need to give this to 1 SF, so that's going to be 2 to 1 SF, which means that the MR should be 124 plus minus 2, because this is to 0 dP, so this has to be to 0 dP as well. Okay, so that's the MR of oxalic acid. Now you're going to tell me, why didn't I just use COH twice and find the MR? Because the question tells you find the MR from these experimental results. So I'm finding the experimental. Now I'm going to find the percentage error in my experiment. So literature value is this much, so then the percentage error is going to be the literature value minus 124. Now I'm not taking 0.6, I'm ignoring this 0.6. This is literature value, but my answer here, this is to 0 dP, which means that I can ignore this one because this is highly accurate. This is highly accurate value, literature value. My experiment is not allowing that much of accuracy, so this is why I'm ignoring the decimal places. Times 100, which is going to give me 1.6%. Percentage uncertainty, 1.6%. State another assumption which may have affected the accuracy of the result. Now, here I'm assuming that all the oxalic, everything that is that mass that I've used the mass of oxalic here, that mass. So I'm assuming that this whole mass here is oxalic acid. So I'm assuming that the oxalic acid is pure. And then I'm also assuming here that this reaction is taking place, which means that I'm assuming that there is no other side reaction other than this. So it's only this reaction that is taking place. So there's two assumptions that I'm making. So that oxalic acid is pure and that no other side reactions take place.